Hello and welcome to the Service Parts Planning and Execution webinar series showing SAP's SPP solution, starting with Session 1, Overview for Management. In this webinar, we will focus on the following core subjects. First, we will talk about where the SAP SPP solution delivers the most benefits. We then address a number of common challenges service parts managers face, and after that we will give you a brief introduction to the SAP SPP solution, followed by a live SPP overview demo. My colleague Ute and myself Christian will guide you through this program. But first, let me give you a short introduction. Westernacher Consulting is a global consulting company with headquarters based in Germany that has a proven track record of implementing SAP solutions since 1994. We are a recognized SAP special expertise partner in the area of supply chain management and provide SAP expertise in the area of customer service, service parts management, supply chain management, and business intelligence. This webinar will be most beneficial to managers with global responsibility for the supply chain network, particularly in distribution-intensive networks, and for the service parts management business. The objective of this webinar is to give you a first impression of the value and core functionality of the SAP SPP solution. There are a series of SAP SPP webinars available, which will focus on each SPP core functions and value in more detail. Let's start with a core question. Where does SPP deliver the most benefits? Well, SPP was developed to deliver most benefits for the service parts business because it addresses very well the typical characteristics that service parts businesses have in common. That is, they operate mainly based on the business model procure or make to stock and maintain a complex supply chain with a large number of different service parts ready for sale. Also very typical for the service parts business environment where SPP delivers most benefits are the sporadic demands of service parts, which are very difficult to predict and where organizations have to handle a high daily order volume and have customers, of course, that expect a high availability of service parts. Also typical for SPP in the area is to cover a multi-sourcing environment where service parts have to be repaired and or exchanged and are used for an additional source to fulfill customer demands. However, it is worth mentioning that not all these service parts business characteristics have to be in place to derive benefits. Based on the implementation experience, and of course depending on the current situation within each organization, an integrated SPP solution can deliver a significant performance improvement. For example, in the area of inventory levels, we can observe a reduction of average inventory levels of up to 20% on one hand, while on the other hand improving service levels up to 20%. Also, we observe an increase of stock turns up to 40% and an increase of delivery performance and a decrease of lost revenues. SPP also has a positive effect on reducing operational costs that can be up to 20%. When we talk about the service parts business where SPP delivers the most benefits, that can be found in various industries such as automotive, industrial machinery and components, high-tech or asset-centric industries such as utilities, aerospace and defense or oil and gas. And based on our experience, most companies across these industries have a common set of key business objectives when it comes to service parts planning. The first core objective is to forecast future demands precisely and cost-effectively for each service part. And second, to ensure the right inventory is available at the right time and at the right place to maximize order fulfillment at minimum inventory and logistics costs. Thirdly, the need to manage the entire global supply chain network from supply chain design to demand, inventory, purchasing and distribution planning in the most efficient and effective way. To achieve and maintain these objectives, companies need to have processes and best-in-class IT systems in place that will support these business objectives today and tomorrow. However, based on our experience, many companies in the service parts business face major common challenges that need to be tackled when it comes to service parts planning. I'm sure that at least one of them sounds familiar to you. Let me just highlight a few of them. We frequently observe that limited visibility of performance and stock in the entire supply chain network seems to be a big challenge for many companies, which could lead to excess stock and delivery problems. Second, often many bespoke demand forecast tools are used that require significant manual intervention. This often leads to imprecise forecasts, excess stock, availability and delivery problems, as well as very high personnel, process and IT costs. The last challenge I want to highlight is that the service parts planning process is not globally coordinated, standardized, or integrated with local service organizations. This can also lead to excess stock, low availability and delivery problems, as well as high operating costs. Now, solving the mentioned challenges service parts managers face is precisely where the SPP solution is extremely strong, as it helps organizations transparently view their entire complex service parts planning and execution process in real time, based on 6 core processes. The first core module is the supply chain design module. This is where an organization models and maps the global service parts distribution networks in SPP. The planning process proceeds along this model supply chain, including all distribution and stocking locations in the entire supply network. The second core module is the demand planning module. The main focus in this module is forecasting future customer demands based on suitable procedures for each phase of the service parts lifecycle. SPP offers sophisticated, advanced, various forecasting models that are selected automatically and run in the background to deliver the best possible forecast. SPP is a self-learning system and always compares the actual demands with the forecasted demands to pick the best fit model on a continuous basis. The third core module is the inventory planning module. This includes the determination of service parts assortment to be stocked at each location, and based on the demand forecast, the calculation of safety stock and economic order quantity, as well as the identification of excess and surplus stock quantities. The fourth module is the supply planning module. Once SPP has determined what service parts need to be stocked in which quantity and location in the inventory planning module, SPP will then determine the necessary replenishment quantities for each stocking location in the network, taking into consideration the time taken to fulfill forecasted customer demands. The fifth module is the supply network collaboration. Actually, this is not part of SPP, and SAP provides another application, therefore, called SAP S&C, Supplier Network Collaboration. While purchased separately, it is fully integrated into the SPP solution. With SAP and S&C, companies have a real-time connection to their suppliers and the suppliers with the purchasers. This drastically improves a company's ability to plan, execute and monitor part orders, shipments and back orders with their suppliers in real time. Not to mention enabling them to assess and monitor the performance of suppliers and rate them and manage them accordingly. The final module is the distribution planning model. Once SPP has determined what products need to be replenished and the suppliers have delivered these parts to the relevant so-called entry location, SPP plans and distributes the products within the network in the most efficient way to ensure they are shipped to where they are needed to satisfy the forecasted customer demands. Across all planning processes, SPP provides monitoring and analysis capabilities that help service parts managers and planners to control and optimize the supply chain on a continuous basis. So all in all, SPP supports achieving the business objective of ensuring demanded service levels are met at minimum inventory levels and operating costs in a highly automated and efficient way. Now, before we start with a short live overview demo, Let me show you the central workplace for a supply chain planner in SPP, the planner's worklist. The layout and the content of the planner's worklist are highly configurable. They can be tailored to the individual roles, responsibilities, and personal needs. The idea of SPP is that we have highly automated planning processes running in the background, and that the planners only manages the exceptions. First, we have the action required area, where certain exceptions have to be handled by the planner, for example, approval of a purchase requisition, very much likely because SPP generated a purchase requisition that exceeded the set budget. The second area is the alert area. Here, the planner needs to intervene to ensure the supply chain performs efficiently. For example, planning data is not maintained or batch processing was not successful. The third area is the monitoring area, where the planner has defined certain queries he needs to do on a regular basis to monitor his processes, such as first indicators for back orders from suppliers. From this work list, the planner can also jump to all the relevant processes to complete the task. This is very user-friendly, convenient, and very efficient. We shall now come to the live overview demo. Now, what will we show you during the SPP demo? First of all, we have two roles. The technical planner, looking ahead in the planning process in dark blue, and the operational planner, who does the daily work based on the results of the technical planning in light blue. In each scenario, the planners do something in SPP that results in an output, which is shown in gray. Firstly, a technical planner runs the demand planning process and gets a forecast as output. Based on the demand forecast, the planner then runs the inventory planning process and gets the results of the safety stock and economic order quantity calculations. The operational planner does the supply planning based on the results of the inventory planning, the outcome of which is a procurement. Finally, based on the supply plan, having received the products from the supplier, the planner now needs to distribute these products into the network. The output of this scenario is the stock transfers that need to be executed. Now let's go to the live demo, which will last for about 10 minutes. I will ask now my colleague Ute to take over.
Thank you, Christian. In this session we will introduce the four main processes of service parts planning that Christian has just outlined. This first process we will take a look at is demand planning, which is part of the strategic planning process. We will start by looking from the viewpoint of a strategic planner. The central workplace for planners is the planner's work list, the layout and content of which can be easily tailored. SPP is highly automated. The planner's work list enables planners to control this automation and manage by exception. You will see how easily that the planner can jump from this work list to any relevant transaction. A planner would need to check if there were any active queries needing attention. Here we see an action is required in the area of forecast approval. Looking at the detail, we see that there is a forecast that is awaiting manual approval for a product called SPM Demo at location 3200. The reason for this is that the deviation from the last to the actual forecast run is 42%. Before approving the forecast, the planner would want to take a look at the details by selecting the forecast option to view the details of this particular product to be uploaded. The planner is now able to view all relevant forecasting data. Let's first have a look at the demand history. The demand history is shown here in the yellow graph. We can see that since the product was introduced in 2008, demand has followed this linear growth trend. We'll now add in the forecast trend and ask SPP to suggest a new improved forecast based on the actual demand. The blue graph shows the historic forecast trend. Whilst the historic forecast follows the steady increasing trend of the demand history, we can see quite clearly that the demand has always been higher than what was forecasted. The new forecast, which is shown here in green, seems to suit the demand curve better. So we will approve the new forecast. This is done by simply clicking this icon, which automatically takes us to the forecast approval transaction. This new forecast will be known as the final forecast for the following planning steps. It seems that the forecasting model was adjusted during the last planning process. In order to apply this improved forecasting model to historic forecasts, we will now recalculate historic forecasts using the new forecast model. The graph describing the historically forecasted demand will be redrawn using the new forecast model. We now see clearly that the historic forecast curve is much closer to the actual demand trend. This improvement is also be apparent in the next planning step, which is part of inventory planning. Now the forecast error, the difference between forecasted demand and actual demand, is significantly lower using the new forecast model. This gives us a greater confidence in the forecast going forward, resulting in a lower safety stock and hence reducing the cost of holding stock. We will now look at the second strategic process, that of inventory planning. We return to the planner's work list where we no longer have an action of a forecast approval, but there is an alert that requires attention. We see this alert is for the same product SPM demo. We now switch into the alert view. We have an approval request for a new lower safety stock level. The planner will also note this positive improvement in his work schedule. This alert says that the safety stock, which is, as we know, based on the new and improved forecasting model with a lower forecast error, deviates too much from the previously safety stock level. From the alert, we can easily switch into the inventory planning book. This planning book again holds all relevant data for the inventory planning, and here is where we will approve the new safety stock level. We first upload the data, and we can see that the old safety stock is double the size of the new safety stock, which is based on the improved forecasting model. The approval is carried out quickly and easily. We can now see that the new safety stock was applied. The confirmation of the alert completes this process. We have seen that improved forecast accuracy within demand planning has positively impacted inventory planning. We will now look at the third business process described earlier by Christian. This is the operational process of supply planning. Operative planning starts with determining the procurement plan, which is calculated on a daily basis. To determine the procurement plan, every location in the distribution structure calculates his net requirement, which is communicated to the parent location. The procurement plan is derived by aggregating all these net requirements to the entry location. In our example, the system will suggest delivery schedules. The planner must manually confirm these delivery schedules whenever the cost of a delivery exceeds a given value. An alert will point this situation out to him. The planner's work list provides him with an overview over all manual confirmation that require action on a daily basis. We now switch to the procurement approval. For our example product, SPM Demo, a manual approval is required. Again, the planner can easily view the relevant details of the situation by switching from the procurement approval to order maintenance. The order maintenance view lists all new and historic delivery schedules, including all orders released to the supplier, supplied, and booked into stock. At this stage, the planner can still make changes to the new suggested delivery schedules prior to releasing the orders. He could, for example, change quantities or change delivery dates for the individual schedules. He can confirm the approval in this view, or alternatively do this directly via his work schedule. The approval will then release the proposed delivery schedules and communicate them to the respective suppliers via the ERP system or via the supplier network collaboration platform. On completion of the procurement, once the goods have been supplied and received at our entry location, the goods must be redistributed to internal locations as required. This is where the distribution planning or deployment comes in to support this process. This is the fourth and final business process described by Christian. Distributing the goods is similar to the procurement part of the planner's work and is normally carried out on a daily basis. This process will cause goods to flow from the entry location to sub-locations following the distribution chains as they have been determined in the distribution structure. The operative planner will only intervene by exception. The planner's work list will show all the necessary details. In our example, any stock transfers of products SPM depot must be authorized manually before they can be executed. The stock transfer approval shows the currently suggested redistributions. The last planning run has led to 2 stock transfers or deployments. 550 units are to be shipped from entry location New York 3000 to child location Chicago 3100, and 648 units are to be shipped from entry location New York to Atlanta 3200. To view the details, we can switch to deployment and inventory balancing. The deployment protocol provides information about the available stock for distribution at our entry location as well as demands within the network. In this case, the number of units at the entry location is sufficient to cover the requirements of all other locations. The stock transfers can now be approved by the planner via his work schedule. They will be transferred to the ERP system after confirming the schedule. I would now like to conclude this brief system demo. I hope this has provided you with better understanding of these 4 SPP processes and demonstrated how user-friendly the planner's work list is. My colleague Christian Schmaus will now continue with a short summary.
Thank you very much indeed, Ute, for this SPP overview live demo. I hope you had a first good impression of how SPP works and what planners can actually do with it. At this stage, I would like to summarize the functional scope and main customer benefits of SPP. We said that SPP completely covers the complex planning process for supply chain planning visible in real time. And main customer benefits that can be achieved with SPP are optimized inventory planning and demand fulfillment through a highly visible mapping of the whole global network via the bill of distribution. We can achieve increased efficiency in planning through standardized, highly automated processes based on the management by exception, and minimized inventory costs within the whole supply network by improved forecasts, optimized inventory levels, as well as a reduction of operating costs through integrated procurement planning and monitoring and optimized distribution execution. What could be the possible next steps? If you think there's potential to improve your supply chain network and planning process, and you want to find out more, we will be happy to do an on-site SPP workshop to get to know your requirements and explore the potential benefits in more detail. If you're then already convinced that SPP will be beneficial to your organization, we can offer you a SPP pre-project, during which we could conduct an SPP fit gap analysis with our own SPP system, assist in building a business case to support the decision-making process, or assess if the preconditions for a successful SPP implementation exist, and if not, make necessary recommendations. Now we have reached the end of this SPP webinar series, part 1. If you would like to get in contact with us, we're happy to serve you. Your contact for North America is my colleague Roberto, for the UK Roger, and for the rest of Europe myself, Christian. At this point I would like to say thank you very much for participating, and I hope that I will see you again in one of our further SPP webinar series we provide. All the best, and see you soon.